Okay, so here's your chapters 1, 2, and 3 review video for your practice test, which is uploaded as a PDF. For the first one, we need to do a modified box plot for the data and identify any outliers. So the first thing that I did is I went in and I put all of this data in Stat under Edit. So now I can go to Stat Plot, make sure that it's on, and it needs to be the one with the 2 dots. So if it's not on, you go in here, make sure that you click on the on, and then down, and then you can scroll through these. You want this one, not this one, the one with the 2 dots, because it says Modified Box Plot. When you hit Graph, you're going to need to do a zoom stat so that you can make sure that you see everything. And so there's my box plot. I have 2 outliers. The lowest, which is a 1.5, then a 2, 2.5, 2.7, 2.95, 3.5, and a 4.5. So on here, what we're going to do is draw this on. And I have this. And then this. And we'll label it. So I have a max of a 4.5. I know that this was a 1.5. And then we're going to fill in our other pieces of data values in there, which I may or may not be able to do. Yeah, if I click off of it, it's going to pull it off. And so you would just now go ahead and label these 3 spots, 5 spots, for your other values. For number 2, I have 32 values listed below, and I want to find the 62nd percentile. So I need to go into my calculator and say 32 times 0.62. And we'll go up to the 20th value. And so I'll count up. Let's see, that's 8, that's 16, 17, 18, 19, 20. So 74 is the value that I would like, because that is your 20th number. For 3, I have a mean of a 32, standard deviation of a 10, and I want to know what's going on when I have a snowfall of 68. So I'm going to say 68 minus 32, get that number, and then divide it by 10. That's a 36 divided by 10. So my z-score is a 3.6. This was 32 times 0.62. Z-score again. I have a test score of a 92.7, mean of a 74, standard deviation of 11. So let's find this, 92.7 minus a 74. Divide that by an 11. So let's see what we get. 92, oops. Oh, it's not going to let me do it. I'll have to close it. 92.7 minus the 74, I get an 18.7 divided by 11, and I get a 1.7. Is that considered unusual? No, because it's within 2 standard deviations of the mean. So 1.7, and it's considered usual. Department store on average has a sales of $28,412.08. Standard deviation of 1,500. On Tuesday, they did $36,266.38. What's Tuesday's z-score? Is that an unusually good day? Well, let's use our calculator. I have a x of 36,266.38. I'm going to need to subtract the 28,412.08. So 7854.3 up on top, divide by the standard deviation of 1500. And it was a very good day, very much so. 5.23 is my, or 5.24 is my z-score, and it was a very good day because this is over, this is more than 2 standard deviations away from the mean. For 6 and 7, you're going to use the two different formulas and two different theories to find out what percentage of data we're talking about. For Chebyshev's theorem, we have that at least 75%, at least 89% rule. Here I have a mean of 66.9, a standard deviation of a 3.4. So what can you tell me about the percentage of adults in the town whose heights are between a 60.1 and a 73.7? Well, it turns out that 66.9 plus 3.4 plus another 3.4 is going to give you 73.7, and 66.9 minus 3.4 minus another 3.4 is going to give you a 60.1. So I'm talking about 2 standard deviations away from the mean. Now the formula is 1 minus 1 over k squared, where k is the number of standard deviations that we're talking about. So 1 minus a 1/4. But it's always going to work out the same way. So really all you need to remember is that if you're 2 standard deviations of the mean, you have at least 75% of the data. And if you were 3 standard deviations away from the mean, then it'd be 1 minus a 1/9, which would be 89% of the data. For an empirical rule, you have that bell curve where within one standard deviation of the mean, if that's my mean, one standard deviation is 34% on each side, so 68%. 2 standard deviations is a 95, and then 3 standard deviations was a 99.7. So now the question just is, if my mean is a 2.6 and my standard deviation is a 4, how many standard deviations are we talking about here? Well, obviously this is going to be up 1 and this is going to be down 1. So we're talking about 68% of my data, according to the empirical rule, will be between 2.2 and a 3. So you'll have both of those rules. You got to make sure that you check for Chebyshev or for empirical. Standard deviation, find mean, median, range. Well, let's put it all into our calculator because then we'll get most of it all right away. Go into Stat Edit. Let's clear this out and put in our data 52, 64, 65, 54, 82, 79, 89, 35, 87. You go out to the main screen, give yourself some space because we're going to go into Stat, Calc, 1 vars. And when we run that, we get a lot of information. Here's your mean. The standard deviation you want is S of X because we're assuming that this is a sample. Your median is a 65, and the range you'll be able to get from 89, your max, minus your min of a 35. So we're going to have a range of 54. So we had, oops, why did it do that? Mean was a 67.4, median is a 65, S of X was, I think, at 18.3, and then the range is your max minus your min, so 89 minus 35, or 54. So you can be able to get pretty much everything from right in there. Make a frequency chart or a histogram given the frequency chart. Use class midpoints for the horizontal scale. Does it appear to be normally distributed? So, looks like we have a max of 10. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the first one goes all the way up to 10. So we can put our bars in. It says use class midpoint. So the midpoint of these guys is add those two numbers together and divide by 2. Class midpoint is a 1. 3 to 5 is a 1. And 3 plus 5 is 8. So my class midpoint is a 4. Next one is a 7. And actually I'm going to do them both at the same time. Oh, those beautiful straight lines there. Class midpoint's a 7. Class midpoint is a 10. Class midpoint is a 13, which is a 1. Class midpoint is a 16, and that's a 4. So it looks something like that. Does it appear to be normally distributed? No, because it does not have a bell curve. It is not bell-shaped. To be a bell shape, you start off low, you peak, and you come back down. So it doesn't have that shape, so it can't be a normal distribution. Change these frequencies to a relative frequency. Relative frequency, just let's make this a percent. Let's see. Let's add up these guys. 11, 26, 34. So to get our frequencies, my relative frequency is just the percent. So 5 divided by 34, which I don't want to lose my number, so I'm going to divide off camera. If I can get my calculator to come up. 5 divided by 34 is a 14.7. We are going to round to the hundredth, so 14.71%. 6 divided by 34, 17.65%. 15 divided by 34, 44.12%, and on and on and on and on. Just each one of these guys divided by the total. And all those completed numbers are on the very last 2 pages for your answer key. All right. What's the difference between continuous and discrete data? Continuous data is basically you can have a fraction of something. There's no leaps in the data, so you can have 1, 1.1, 1.11, 1.12. Discrete data has jumps, so you can have 1, you can have 2, you can have 3, but you can't have, 1.5. No, 2 2/3. None of those. It has to be an integer for you to have the discrete data, or a natural number, since we're probably not going to be dealing with any negatives. Relationship between a population and a sample. Population is everything. That's if you talk to everybody that fits that description, that's your population. A sample is a portion of the population. So you want to find out how the people in Mecklenburg feel about taxes going up or their water bill going up, like I just got in the mail the other day. You're probably not going to hit everybody in Mecklenburg County, but you will get a well-defined enough sample of that it would be a good representation of how the population truly feels. Stratified is when you have a 2-step process. So maybe you break it up into boys and girls, and then it's ages under 14 and then 15 and up. Or you have men and women, people with children, people without children, something like that. Systematic is that you're picking out of the random, but not picking randomly. So you have everybody, but you're going to pick with a purpose. So you have everything, and you're going to take the 10th person in the list. You're going to take the third number that you pull out of the hat, or every third number that you pull out of the hat. Every 10th person, every 10th letter you receive, you'll read, something like that. Convenience is just whoever happens to be there. So convenience is, I ask you to poll students of Mitchell Community College, and you're like, well, I'm just going to go chill out in the parking lot, and whoever comes by, that's who I'm going to ask. That's a convenience. I need to, like the Girl Scouts. The Girl Scouts go around, sell cookies, they hit everybody in their neighborhood because it's convenient. Everybody's just right there. You're just going to kind of go to one place, and whatever happens, happens. Clinic gives a drug to a group of 10 patients, a placebo, and a placebo to another group. Is this an observation or an experiment? This is going to be experiment because you're doing something. If you're giving something to a group, or you're breaking people up into groups, then you're talking about an experiment. An observational study is just that. You show up and watch. So like in education, we get observations. You'll probably see my boss come in sometime during the semester. She just shows up and watch to see what happened. If they wanted to do an experiment about teaching styles, they may tell me, all right, Tony, you got to teach, chapters 2 and 3, and then we're going to have Miss Townsend do 4 and 5, and then we're going to see what happens. That would be an experiment. For 15, and it will not necessarily be a stem and leaf and a dot plot or something like that, but you're going to have a set of data. And basically the question is going to be, how would you organize this data, and why would you organize it like that? Given the data I have here, let's see, I got 17 to 20. I would probably use a dot plot since I have a very small range. However, you could use a stem and leaf because I have a stem and a leaf, right? I got the 1s and I got the 2s that I could use. And so you can get an idea of your data that way. If you didn't have a tens digit, then you wouldn't want to use a stem and a leaf because you have no stem, you just got leaves. If this data was very wide, maybe from 1 to 50, I may not want to use a dot plot because I'm going to have this gigantic line. I may want to use a stem and a leaf. I always ask an extra credit. My extra credit will be, well, I'm kind of between two. It's either going to be about the different charts, like Pareto or, ogive or any of those, or it's going to be about types of experiments, which we didn't talk about a whole lot since we really won't use that information in our chart, but there's retrospective, there's cross-sectional. I believe that's in chapter 1, and the charts are in chapter 2. And so that's it. That's your whole test. That's not as bad as it looks. You have on these back pages, which I believe I corrected, your answer key for everything, except for that last one because answers will vary. You may want to say one thing and somebody else says another. But you have your samples here and how that works. And that's all I have for you.